Hello friends, today actually we will be looking into the full text search feature of Postgres. Earlier we were saying that Postgres is being used a lot for uh, NoSQL as well as full search capabilities. That is, you can actually think of Postgres as a combination of MongoDB and Elasticsearch. So it is giving you all the powers of a RDBMS as well as a full text search capability of Elasticsearch and MongoDB, that is JSON capabilities, like unstructured data searching capabilities as well as this capabilities. So it has become an all-rounder in terms of the functionality. It is giving you all the functionality required by, that's given by separate. Or you may also have heard of timescale DB, that is actually used for storing time series data. It is also Postgres based one, but it's extremely fast. It has compared to a specific use case based database. So I am not comparing that with the normal PostgreSQL that you find in the PostgreSQL site, or whatever you get in the AWS, it is Aurora, RDS, or even Azure, Google, or anything by the cloud providers. So what we will be actually trying to see here is the full search capabilities alone. Okay, here the first one, that is the 2TS. This is actually 2TS vector and TS query. These are the two things that is extremely important, and you will be coming across again and again in full search capabilities. If you are having a query, that is, if you are giving something like two terms you are giving, how and search. When you have to search inside a string like this, it will be actually annotated like that. It is 2TS vector at 2TS query. Actually, we are actually converting it to the query like this. So you can see it is showing that we already it is shown as true. That means it has found that a particular query inside this string. Again, you want to highlight something. You want to highlight a string. This is how you will be doing that. See, we have highlighted it. See, this is actually called headline. Actually, in Google and other things, we have a lot of I mean, long text and other things. They will give you a summary. That is the headline that is provided like this. If they will give that for specific search terms again and everywhere. So you will be wondering what happened to the how. Actually, how will be omitted. Normally, that is what happens. See, I can show you in a different way how what actually is TS query and how. See, this is the only term that is returned by normalize. We call it as normalization. How is actually a general term. Search is actually the term that they have identified as a searchable. So if I'm giving it something like Constantine, that is not in the dictionary, that is not omitted by 2TS query. See this. that is actually a mistake. Like that. So again, you can see that both search or Constantine is there, and actually the way it handles it will be very different. That actually we will come across different ways of how to generate a TS query, how to create one in various ways like phrase, plain, and web search like that. So I have actually created a test table for you, a block table. It is actually loaded with a lot of data. This actually shows you some demographics. This is having more than just to show you the power of Postgres. Okay, Postgres food test search. I can show you. This is uh, if you see the maximum length of content inside the blog is more than 1700 characters. Minimum is 84 characters, and it is having more than 1.2 million records. That is it's not very simple use case. Actually, it is a very nice use case. I think you can do that same thing for a very big database as well. I mean, even if it goes to say uh, five around okay 5 million or 10 million, it will be nice to search. I mean, it gives you almost same performance, very nice performance. I actually didn't have much issues while searching billions of records. Okay, so this is actually to show, just to show you how this one actually we have created all these things just just to show you how it is done. Okay, and actually I will explain you what it is, because some people may not know what exactly it is doing. So id integer not null, actually this is this particular is actually creating a primary key, a sequential primary key. Okay, then the next one is the title, and if you notice that we have given is no not null everywhere. Everywhere it is not null except tsvector. Tsvector will be by default not null, because here uh, the content and title is not null, and it is actually a derived column. We actually populate using a trigger, that is the advised method by the Postgres. Okay, so again, if we come across, we have a blog date. It is the default current date, and author. Everything is not null. Okay, here the type you may not have seen, tsvector is given. Tsvector is actually derived from title and content. Okay, block primary key is id. Okay, that is from sequence, or actually we give it as serial only. Serial is converted to sequence, and here see we have indexed it. Okay, we are using gin index. Okay, so earlier I think I have to already told you gin index is specific for this particular text type of searches, that is full text search. Okay, here where is it? DX blog author is there. Here it is. Okay, this is the one we are interested in. See, you can see that we already we have created a index idx block ts, again using gin index. Okay, public blog, it is on table public blog using gin index on ts. Ts is the field. This is what we have given here. Again we have given certain other indexes also. One is a compound index, one date and author, okay, and second one again is the author alone. See, if you can see here, it is date descending means it always shows the latest date first, okay, and okay, ascending author. Okay. How we are actually creating it is using a trigger. You can see that this is actually the advised way by Postgres. Okay, so actually we can actually give it as a calculated column. Okay, so we can actually calculate it and give that there itself, but and give storage. But difference is that this is actually a bit faster than the calculated fields. So if you see here, we have given trigger name before insert or update. Okay, for before inserted update means every time it is going to insert, it will execute this one. For on block, the table block, for each row this has to be done. Okay, execute function block ts, this is the function, okay, for block ts trigger. So this trigger, what happens is we are having uh, anything new, that is before insertion. If there is actually two uh, what is two states, that is before and after, new and old. Okay, so this is new. So new ts means every time coming here it gives set weight. Set weight function, yet another way to identify if the title is having, if the title is having something, I mean we give it as a title is having a keyword, we give it as a higher, we give a higher weight. And if the content is having the keyword, we give it as a give it a bit lower weight. This is what actually now normally what we do. This is what's happening here, and this concatenation symbol as discussed earlier. This is actually continuation of earlier videos. So if you have any doubts, please actually refer that also. Previous videos also you have to refer. This is very nice. I mean, I'm just going through this because some people may be finding it a bit difficult, but actually, uh, though you will be coming across this multiple times everywhere. This is how actually we generated the test data. Okay, we actually selected all these things, and we I mean, we generated some data, that is 1 million. We generated 1 million records and inserted it here, and by replacing what is that dollars from the cache words. I mean, there is no much uh, since we are using the regular expression replace. Actually, it is quite fast. It replaces very well, and I can do that very. I mean, it is fast. Or you can actually write a function on your own, whatever you want to do, instead of what is that cache words. Now this cache words is a function that's provided by Postgres itself. So I'm just replacing all these things. Again, inside that, again you come across G, the same thing that we actually saw the last time. Okay, G is actually continuous searching, but that is not required at the moment. And this Constantine is actually saying it is the author. This one, select, this is the title. Okay, it's the title. Next is the content is having this value. This is actually concatenating, and everything goes inside, or other is coming here, like that. This is where the whole generation happens. This actually returns a set. Okay. So you have to be understand what it does, understand what it does. So if you want to actually to see how it actually handles this, yeah, see this, how fast it is. Just I think it is just 0.19 milliseconds, 0.19 milliseconds to search 1.2 million records. That's how fast it is. And for all practical purpose, it is actually efficient as uh, what is that, Elasticsearch. It is very good. Some people doesn't want Elasticsearch to come in at some places because it introduces the complexity of new technology there. Otherwise, they will allow it. Okay. Okay. This is again. This is another set of data that we inserted. There's two sets of data. This is the next set of data. Uh, Again, we are actually doing same thing here. I think the only difference is the name has changed, and we are actually reading data from this text file. So this text file operating it here. So what happens is whenever we read data by default, what happens is any new line character it inserts as a new record. We have only one field, so actually we have to create an aggregate here. That's what happens. The string aggregation is happening. Okay. Everything goes as normal. So this one may not work. Everything you can give character 10 or something for new line character. It will be working. So there I inserted 1 million record. Here I inserted 200,000 records, and the count is actually as I showed as I shown you 1.2 million records. Again, we search. We already searched it. We just take on 0.19 ms milliseconds. And you can actually do a lot of search in this table. I will just roughly explain you what it is. Java and means you have to find Java keyword, as well as it should not have 100 and it should have 1000. So you can actually find the count, how many records are there, you can find. So again, next one what I am saying is, again I am finding 1 and 100 and not 1000. So it should not have 1000. That is the meaning. It should have 1 and 100 but not 1000 strings. All these are quite fast. Just check it. It is just taking few milliseconds. I mean, actually, you may be seeing a lot of time more than what it should. Actually, it is actually retrieving data and displaying it here. There's some lag on that. Otherwise, it is quite fast process. Console right, I go the operations is a bit slow. Actually, I told you there is a different ways of creating query. This is one of them. Okay, from plain text to TS query. So it created, inserted all ampersand symbols. Okay, again the phrase. This is the phrase to TS query. Actually, what is the difference between phrase and plain? Is that plain is just created as normal queries, or I mean query TS query only. But phrase, what happens is it has relation with the previous strings. Whatever previous strings we are having, it is having some relation with that. So that is the difference between a phrase and a plain. Okay, let's see this. That's the difference. So it says these are all related. Okay. In web search is actually having more complex syntaxes. Actually, you can do anything. I mean, if you want to, this actually says this is negative. I mean, this is not there. This, if you can give this and this or like that. So we say almost same. You see, not Java or 1000. This is or. This is and not Java. See, this is how it is. Again, because I am not actually going very much in depth, because you have to work again and again, because there are a lot of things that you should know. That's why I'm not actually going much into all these things. Here, what we are coming into something new called rank. Okay, ranking is actually required to identify which is the best search, so that we can higher the we can bring it to the top. Everything is one. Okay, I can just give a brief description. From TS, I'm finding the rank using the query. Query is actually from here. See, log to TS query. This is the thing. We're using query here. Okay, resume and summary. And where TS query, TS at query, order by rank. This is what we have given here. And give here ascending means you show the lowest first. See, it just takes few milliseconds. Every time it just takes few milliseconds. The same as earlier what we discussed here setline. Concatenating. Here we are concatenating title and content. Again we are just finding resume there. if you actually give, because there is more than 200,000 records, it will be returning more than 200,000 records. That's why it is delayed. Computation is actually quite fast. If you can give that limit here, it will be much faster. Quite fast, right? Okay. Uh, this is all about today's video session. If you like it or you want more explanation on what it's doing, you can just comment me. I actually gave you a rough idea of what is happening. I mean, I am not saying that it is a complete class or a complete video lecture or something. It is simply speaking, it will just give you an introduction to the things that we can use every day, and how all you can use it. See, I'm just going through it once again. See, we are using tsvector and tsquery. Every time we go, just find that one again. Tsquery is there, and it actually converts into the normally. I mean, it converts into normalization and inserts ampersand symbol like that. Then we are researching it inside. Headline is actually used for highlighting, and find we are actually doing a very big we have generated a very big table for this purpose. We have created I mean we are actually checking things here, but it is all not actually very much relevant. Things is that this TS vector is important, title, content, author is important. We have actually didn't use much of the things, and here where is that? Yeah, we are using gin index on this. Using this gin index, we will be actually computing everything. Okay, so again we are saying that we have used the trigger on this particular function. Okay, that table is there. For this table we have created this trigger. This trigger is calling this particular function, and so everything is actually interrelated. That's why I just came and I just want to, actually you can just make just just think of, we have used wait as well, so that every time you find a keyword inside title, it is having a higher rank, okay, or a higher weightage. So we created inserted things and went through all these things. Yeah, that's nice. Thanks for watching. Please subscribe, like and share with others. Okay, thank you very much.